Okay, moving on with the test 4-5 practice. Now we're getting into questions that involve trigonometric equations. And so right off the bat, we're asked the two solutions of the equation sine theta equals 1/2 are blank and blank. Now, most of these equations can be easy and or quick to solve if you still have a good understanding of your unit circle. Now, the sine function, of course, is asking about y values inside of the unit circle, and we're asking where do the y values equal 1/2? Well, that happens at this position and this position, the first and the last angled position before horizontal. So this angle correlates to the 30-degree mark, this one 150 degrees. But as you'll notice with the multiple choice options, and you may have picked up most recently, we're pretty much done with degree angle measures for this unit. We've got to be thinking about radians. So in terms of radians, we are dealing with pi over 6 and 5 pi over 6. And those would be the solutions that we're after in this problem. So I would go with, looks like choice 3, and that's what my answer key suggests as well. For number 18, we have a bit of a more involved equation, but again, the use of a unit circle is going to be quite helpful here. So if I've got 2 sine theta plus 4 equals 3, I would subtract 4 from both sides and then divide by 2. So that would mean that sine theta is equal to negative 1/2. And now we're at an equation that looks just like the problem before, where in the unit circle do the y values equal negative 1/2? Well, that's here and here, although it would be a bit more appropriate to say here and here. Since we are looking for solutions between 0 and 2 pi, I don't want to report this angle as negative pi over 6. That doesn't land in the domain. So instead, I'll say 11 pi over 6. Now the solution set, you can see the squiggly brackets here, the squiggly braces. Was never good at drawing those, but the solutions are 2. We've got 7 pi over 6 for this angle and 11 pi over 6 for this angle. With 19, we'll approach this in a very similar way. I'll divide both sides by 4 and then take a square root. So we know that cosine squared is equal to 3/4. Cosine by itself, after we take the square root of both sides, well, let me just think about this mentally for a second. That would be the square root of 3 over the square root of 4, which is just the square root of 3 over 2, which is fine. That's well and good. But back here, we had to put the square root symbol on paper. And anytime that we introduce the square root symbol to solve an equation, we've got to be prepared for both positive and negative solutions. So now we're looking at cosine theta equals positive and negative radical 3 over 2. So with that in mind, where does our x value, cosine references our x value, where does our x value equal a positive or negative radical 3 over 2? Excuse me. Well, that happens 4 times. 1, 2, 3, and 4. These two positions produce the positive square root of 3 over 2 for our cosine value, and these two angles represent negative square root 3 over 2. So those two angles, of course, using our braces for several solutions, occur at pi over 6. Now I'm going to keep rotating in this direction because we need to report our answers in the interval 0 to 2 pi. So we've got pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And that seems to match the answer key just fine. For number 20, I would add 6 to both sides and then divide by 8. So we now have sine squared equals positive 6 divided by 8. Well, that's 3/4. And we're encountering a question very similar to the last. When I take a square root on both sides, we need to introduce the positive and negative symbol. And the square root of 3 remains in the numerator, but the square root of 4 turns into 2 in the denominator. So where in our unit circle does the y value equal positive or negative radical 3 over 2? Well, that's those positions. So we're dealing with pi over 3, 2 pi over 3, let's see, 3 pi over 3, 4 pi over 3, and 5 pi over 3. A little rusty with my unit circle, so I couldn't remember. But pi over 3 is easy for me to remember. There's 1 over 3, 2 over 3, 3 over 3, 4, 5, and 6 pi over 3. So 1 pi over 3, 2 pi over 3, 4 pi, and 5 pi over 3. That seems to match the answer key just fine. Okay, now on this one, number 21, we've got to be real careful here. There was something that I mentioned last week when we were solving these. Anytime that there's a multiplier or a number that's being added or subtracted inside the grouping symbol within the trig function, that indicates the number of rotations around the unit circle we're going to have to travel in order to find our solutions. Or it represents the offset or the rotation to find our solutions. In this case, there's a 3 here, so when I identify the solution to sine, I'm actually going to consider 3 trips around the unit circle in order to find all possible solutions. Here's the reason why. Solving for the theta value on the interior of the grouping symbol can be difficult, so a lot of times I just treat that as an x. And so I ask myself, well, when does sine of x equal 1? Well, sine of x equals 1 right here. The only angle measure that's got a y value equal to 1 is at 90 degrees, which is pi over 2. However, pi over 2 is not the solution for theta. Pi over 2 is the solution for x. Now, if x is used for, 3 theta, then theta by itself is equal to x divided by 3. Well, that's easy then. What was a solution at pi over 2, me saying that x is equal to pi over 2 represents a solution. Well, x divided by 3 would be pi over 2 divided by 3 as well, because again, we're trying to solve for theta here. Theta is x divided by 3, so x was pi over 2. If we divide that by 3, we're now looking at pi over 6 as a solution. Now, that's one of the solutions that exist between 0 and 2 pi, but it's not all of the solutions. You'll notice real quickly down here that there are 3 solutions. We obtain those solutions by traveling around the unit circle again. So if I do an additional rotation, that's going to land me back in the same position. This is the only spot where sine is equal to positive 1. So this additional rotation is now talking about not angle pi over 2, but an additional 2 pi radians, or 4 pi over 2 radians, which is 5 pi over 2. But here again, if x was equal to 5 pi over 2, then theta is equal to 5 pi over 2 divided by 3, which gives me 5 pi over 6. And here's another angle. This is another angle that exists inside this domain. And that was, one answer. A second answer came from an additional trip around the unit circle. So our third answer is going to come from another trip around the unit circle. So we're not talking about angle measure pi over 2 or 5 pi over 2, but we're talking about the next angle measure after another rotation. And this would be an additional 4 pi over 2 on top, which makes this 9 pi over 2. Divide that by 3, and now we're looking at 9 pi over 6, which can be reduced. Both of those have a factor of 3, so we'll call this one 3 pi over 2. And there's a third solution. Now, if you didn't pick up on my hints from last week saying that this 3 implies that there are 3 rotations around the unit circle, well, you might go a step farther and say, okay, well, we found 3. What if there's a fourth one? Well, again, add 4 pi over 2 to indicate another rotation. We're now talking about 13 pi over 2 that needs to be divided by 3. And that yields 13 pi divided by 6. But now 13 pi over 6, this is a theta value that exists beyond a unit circle. The unit circle stops after we get to 12 pi over 6. 13 pi over 6 would be a full rotation plus an additional pi over 6. And so this is the first solution that doesn't fit into our domain that was described back here at the beginning. So pi over 6, 5 pi over 6, and 9 pi over 6, or 3 pi over 2, are the solutions that we're after here. I'll go ahead and stop this video and pick up with some more problems in the next one.